Welcome all to my fourth lecture. In this lecture, we will start writing our own function, our own code. We'll try to take different examples, show you to write the code, and also I'll try to show you some debugging as well. I hope you have successfully watched my 1, 2, 3 lectures and you are also sitting at the same page where you are able to install the VS Code and we are in a position to write, compile, and debug the code. So in this lecture is also a very interesting lecture where I will try to show you various different examples and along with some compiling and debugging as well. So let's jump into the video. So before starting the uh, lecture, so let's try to understand what is a function call. So function call is nothing but where you are actually calling the function. Function definition, where you are defining the function, the execution, or the function body is being given. And then what we have is function declaration, where you will define, what is the data type, is it a void, then function name, and then the data type, which is the argument, and the variable name. So this variable is nothing but a local variable, what you are passing or what you have in the function definition. And wherever you are calling the function call, normally this variable is nothing but a global variable. And also one more thing which is very interesting is if the function is defined before calling the function, then no need of having any function declaration, which I will show you in the next slide. So maybe let's try to uh, copy this program. Now let's go to Visual Studio Code. So in the previous video, I tried to show you some example code with I tried to show you what is a makefile and how will you do some compiling and debugging. So I'm starting with the same same place, means like I have my launch.json file. I also have my makefile. Now let's try to uh, create a main.c file. So what I'll do is file, new file, and just I'll type main.c. So sometimes what happens is like the main.c file will get generated inside the .vs code. So when you try to, if you just type, if let's, for example, if I'm trying to type main.h, so now sometimes the file will go inside the VS code. So this you should take care, because the make file should be in the same folder or in the same file location of the main.c file. Now I'll try to copy this. So I just copied this. Then you can see there are some errors. So the compiler is not getting recognized this uint16. To fix this, let's try to let's try to have a standard. So the standard data type is typed of unsigned int. So this I want to replace with a short name. So that is what my intention is. So I'll just try to do this. Yeah. So now what we are trying to do is we are having a global variables a as 10, b as 5. Inside and calling the function, even in the function, the local variable also I'm trying to give the same names a and b. And then I'm trying to rewrite the values what you received in a local, like a is equal to 15, b is equal to 25. So the question is, when I do the printf a comma b, will be the value 15 or 25, or will be the value will be the global values. So the answer is inside this a and b is a local variable, and inside this function, even if you change the values, the value will not get changed. So let's try to see that. So what I'm trying to do is I will just go to view terminal. So I think that is what you're sitting here. So inside this folder, I'll just type make. So the compiler will recognize the make file, and then it says maybe it is having some errors. What does this error in function add? Yeah, so the problem here is this function, we do not declare the function. So what I'll do is I'll just, before the function call itself, I'll try to like define the function. Then then the compiler will identify, okay, add means, because the compiler will always start from the top to bottom, so it will see this function. So this function is already defined. Then if you have a function call, then there is no need of function declaration, right? So now let's try to type make. Then you can see the output.exe file got generated, and that object file also got generated. Yeah, C is not used because, yeah, we are just, it's a void function. I want to start with a void. So C is equal to A plus B. It's a void function. So it is the reason why you are getting an warning. Now, if you want to debug, then you just want to go start debugging. Yeah, then it will open uh, an external console, because we have given external console as true. Then if you try to go to the step in, then you can see the value in the external console will, like, yeah, maybe let's try to do this. Yeah, so you can see the why the external. Maybe let's try to do once more, maybe. Yeah, so let's try to do the debugging again. Okay, you are sitting here, and then when you run it, you can see the external console. Yeah, maybe 10.5. Yeah, so you can see the global variable values will remain the same. Even though you try to change inside the function, the value will not get changed. So that is what the first example. Now maybe let's try to see, let's try to paste this function definition after the function call. So now the compiler will not recognize. So let's try to try to make a main.h file. So I'll try to include this main.h file in .h file. Yes, so the main.h file is included. Now let's try to copy this as well. So now I'm trying to I'm trying to just have the function declaration, right? So I just have this. So now the problem is the user defined data type is no longer, is not getting recognized by the compiler, because it starts with main.h, then it's asking to include the main.h file, and in the main.h file, this the definition of these data types are not available, right? So that is the reason why you are getting the error. So now we are good to address that error. Now let's try to yeah, do the same. So you can, like, you can see the same. So you have a small warning saying that C is not getting used. So this is our first example. So hope you got some insights. So now let's go to the second example. Okay, second example also, it's quite simple, but I just want to have a yeah, I just want to have a return data type. So what I'll just do is, everything will remain same. I'll just paste here, and then maybe let's try to remove the breakpoints, and then also you want to yeah, have the new function, yeah, function declaration, right? So now what I'm trying to do, you are defining a b. So the variables are passed, a comma b. You can just have different names also. It really doesn't matter, right? So you can have c, d, whatever it may be. Only thing is, okay, you just type c, d, and then you are trying to return, and then you want to assign that value to the global variable, that is nothing but C, right? So now how does, so in place of void, so here the return type, the data type should be mentioned. So that is what The next point is, so now let's try to maybe now let's try to do a make. So uh, it will try to, okay, so basically it's only 1%, because I'm just trying to have one value. So yeah, no, there is no more warning. Now let's try to just go debug. So you can see the uh, yeah, you can see the value 15 is getting displayed. Okay, so this is our next example which we are seeing. So now let's try to jump to the structure example. So before going to the structure example, what I want to do is I really want to copy some available header file. So C2000 4300. Let's try to go to device support. Let's go to 280015X, which is the controller which we'll refer in this video lectures. Now go to headers, source, or maybe sorry, include, and then let's try to copy this gpu.header file and just directly paste in our example. So our example is Visual Code and then videos. Yeah, so this is what my place is, lecture 4. I'll just paste over here. Then you can see it comes directly. Yeah, you can see this is getting like it come over here. Now what we will do is maybe to, so you can see maybe the compiler will not recognize this like data type. So what we will do is we just do some rearranging. So inside the main.h, we have this data type. So I'll just copy this inside this header file so that you know basically this will understand, okay, this is the data type. Also, here you can also see there exists the 32-bit one. So I'll try to do the long data type as well. Okay, so yeah, so we have now we can see there will be no more errors. Then one thing you should be very careful is you should first include the header file whatever we have just, yeah. Okay, so now you have this function. So the compiler will see the user defined data type. Then you are having the main.h. Okay, so this should be the flow. So now let's try to see the example. So I have a small example. I'll try to paste and then try to explain you with some facts. Yeah. So what do we have? Okay. So we are having a very simple example, like the GPA set rec I'm taking. The union is defined in the header file. I'm taking only this particular union, right? Then I created an instance or a variable. So if you just have a declaration, we have seen in our previous videos, if you just have a just a structure without an instance, it will not have any memory location. So basically you want to create an instance. So I have created an instance for this variable, and then I'm trying to access the whole bits directly with some ff. I'm directly passing the whole value to the whole union, and then I'm having a function name. So this function name is nothing but, so which we should try to give over here, right? So let's try to do this. So we have declared the function and name in the main.h file. And also I highly recommend you to type rebuild clean all in the make file, which we have missed in our previous lecture. Now you come to the terminal and then type make. So you can see the new files gets created. Now let's try to launch or debug the code. So you can see the you can see the values will get updated, and in the console also you can see the value got updated with 255 whatever we have passed. So now let's jump to the next example, that is 3.2. So here, rather than I'm taking what I'm trying to take is the structure, not the union. So everything will remain same. So let's try to copy this part of code. So we'll try to copy this. So we can see. So I'm trying to take the GPU structure rather than the union. Now the data type, the GPU set bits, I'm calling with or creating an instance called bit. So only one element I'm trying to write, but what I'm passing is the whole structure, not the single element. So as I'm passing the whole structure, you should also try to have the same data type. So the data type of bit is nothing but struct, and the struct tag name is GPA set bit. So I've given the name. So bit access GPA.0, I'm trying to pass to a local variable. So now you should also try to like update the values over here. So yeah, so I have done that as well. And now if you try to saved it, and then when you try to make it, you can see the values will get updated. And then if you try to do the step over, you can see the, if I want to type the GPIO 0, I think you're already seen the value as 1. So this is our next example. So rather than union, we are passing the struct as a data type. So maybe now let's jump to the next example. So this example is also very interesting. Uh, so now you have the whole structure, but I really don't want to, pass the whole structure. I just want to have a single element. I want to have a single element. So maybe let's try to just modify the code bit dot GPIO 0. I'm passing the the only one single bit. So you have to see now the GPIO 0 is of data type unsigned 16. So you should have the same data type to the function, but somehow you're we are not doing that. Then you can see that it will show some errors. What the error shows, it says argument of type unsigned 16. So the argument type is unsigned 16, but you're passing to a local structure. How will you remove this? So just very simple. So what you want to do is just have an unsigned 16, and then just call it as A, B, or whatever it may be. Like whatever the name you want, you can just give that. Now your problem will get solved. So so now let's try to do that as well. Yes, so now your problem got solved. Now let's do a quick debugging as well. So you can see the the value will get updated as 1, right? And you had seen, so every time, sometimes when you do some coding, you can see you're getting some data mismatch type errors. So you should really understand the fundamental, then you will not face much challenges to solve the problem. So now we are all talking about like the structure as an argument. Now let's try to do some return data type. So that is what I want to focus here. So let's try to jump into that portion. So what we are trying to do is very simple again. We have taken some variable. So I have my GPO set rec, which is an union. And now what I'm trying to do is I'm passing this some global variable structure. So that is the reason why like I have this unsigned 16. But what I'm trying to return, I want to return to the whole, whole union. How to do that? It's very simple. So you should have a of the same data type. So the return is data type is union GPS set track. So you should have the same data type, or like the variable bits also should have the same data type. So the data types of bits is also the union GPS set right, so that the problem will get solved. So we have the 10 value which will get passed. So the 10 is getting, we are passing the whole 10 to the whole structure. And now the reg L value, whatever you have passed, you want to pass to a different instance. So that is nothing but the bits. So now let's try to do the, let's try to now update the main.h file as well. So we have updated this file. So now let's go to make.c and then let's quickly do it make. You can see, yeah, they are saying that the first D, because it's not a single, like not a single integer. So that's what it is trying to say. So maybe let's try to see the value in the local variable itself. So now you can see the bits. So if I try to type bits, you can see the value will get updated. So if you see 10, if you debug, so it's 1010. So you can see the GPA 1 and GPA 3 alone got updated. So this is our next example. What I would like to show over here. The next example is like having an argument as an enum function called with an enum as an argument. So we had seen in our videos what does enum means. So now let's try to copy this part as well. So I have copied this. So maybe here I want to use the example again from TI, but maybe from a different place. So let's go to driver lib. Let's go to F200. We have this driver lib. Then maybe let's try to open the GPO.h file. Open. Then maybe let's try to find the GPO port. Yeah, I just want to use this. I'm not copying or anything. I just want to use this. So in the main.h, what I'll do is just I'll have a I just defined this GPO port. Now I'll come over here, and then what I'm trying to do is I'll just copy this as well. So now this is what. Yep. Yeah. So what I'm trying to do is I'm creating an instance of the enum. So this is the data type port, which can have any of the values like the GPA, B, or H. So port is created, and then I'm passing a value to the port, to this variable or GPA port B, and passing an argument as an enum. So I'm passing an argument as an enum. So when you have this variable, you should have the same data type. So that is the reason why I just had the same data type, and then I'm passing that like a value to a global variable. So you can see the value will get updated. So now let's try to make and then try to debug it. So you can see uh, the value will get updated. So if I try to type the B, so the B basically it's port B, so B is 1. So you can see the value will get updated. So the value from 5 it got updated to 1. So this is what the next example, what I want to show, the enum as an argument. Now let's quickly jump to the next example. So the next example is nothing but a return data type. So this is also a very simple example. I'm just trying to show you some basics, nothing much, not so like something very complex, but I'm trying to show you some real examples. So what here in this function, okay, what I'm doing is I'm just having one more instance of this port, and I'm trying to pass this to a I just created some variable port of enum passed to B, and then I'm trying to update with a port data, which is a new variable. So the data, whatever the return port data, whatever you are assigning, it should have the same data type. So that is the reason why it's GPO port. So here you just want to copy this, and then you just want to update this value or this function declaration over here. So yeah, you can see the value will get updated. It's all simple programs which I'm trying to show you on a real-time basis. So now if you try to do the debugging of this, you can see the port data. So these all variables are not existing anymore. So only thing what we have is port data. So you can see the port data is getting updated with GPU B. Okay. So this is also something very interesting. So now I really want you to touch some electronics into this topic. How will you write some, let's assume that you want to write some function. Let's say assume that you want to have a low pass filter or maybe some integrator to different input signals. So I really want to show you some simple example. How will you write a function using some structures? So now let's try to do a implementation of discrete integrator to this example. So let's assume that you have a continuous signal x of t. I want to discretize it. So I take two samples, x of n and x of n minus 1. So if I want to find the difference dx by dt, so which is nothing but you want to take two samples, x of t1 minus x of t naught. So if I enter discrete domain, this is nothing but x of n minus x of n minus 1. And then you're having something called TS, which is nothing but the sampling time. The time difference where the samples is taken. So TS, so this is nothing but the sampling time. So now if you try to see this dx by dt, we know that in the continuous domain, it's S. So S can be replaced with 1 minus Z minus 1 divided by TS. So this is the popular method called as backward Euler method. So we are trying to, we know the previous sample. So that is the reason why we are calling it as backward Euler method. And now if I want to, what I'll do is, let's assume that this is what the integrator, what you want to implement. X of s is the input, x of s you want to integrate. So let's assume that you are having the x of s as input, you want to have y of s, and then you want to do some integration to this x of s signal. So x of s by s. So if you want to do that, how will you do that? Is just, if I try to take this signal over here, I will get y of s into 1 minus z minus 1, right? X of n into ts. Now if I take y of s into 1, so it's y of n. Y of n is nothing but x of n into ts, x of n into ts, plus z minus 1 is nothing but y of n minus 1, y of n minus 1, y of n minus 1. So this is what you want to implement in a discrete domain, right? So now let's see how will you implement this function using using a uh, C code. So now let's try to uh, copy this. So what you want to first you want to have is the structure type. So let's copy this structure type. So I'll just come over here. I'll come to main.h and then I'll just do this. So what we have, we need a sampling time, right? So we have to mention what is the sampling time of your signal, what you want to sample. Previous output signal, you want to know what is the previous output signal. What is the present output signal? So present output signal is nothing but y of n. Maybe let's try to try to write this as well, y of n. So y of n is a present value y of n, and this is nothing but y of n minus 1, and this is nothing but your uh, the sampling time, yes, and then this is nothing but your input signal x of n. So these are the inputs. So I just try to create uh, a structure with some name as integrator, right? So I just saved it, and now let's try to jump to the next part. So what I will do is I just made the program for you all. So I have two parts of program. I'll try to explain you with proper data. So let's try to do this. Yes. Now let's try to go slowly. Okay. So integrator, it's a structure. First, I'm creating. Let's assume that I want to create two variables. I want to do an integration to two different variables. One, let's assume that it's an input voltage. Another is nothing but input current. So I'm giving a first you want to give the what is the existing value. So if it is some input from ADC, you want to take the ADC input and then you want to pass to this input signal value. Uh, but here we are just showing some examples. So I want to initialize the value to some non-value. So you can do in this format. So the initial output signal value and the present value and the previous value I just mentioned as 0. Sampling time I just mentioned as 0, 1. So that's the reason why you can see the values, everything I've defined in a floating format. And now the integrator, which is of input current. So this also I'm giving, but I'm trying to give a different sampling time. I just had a just had a like some global variable I. So now let's say that I want to use the same function, right? No, that is a purpose. I really don't want to create again the same function. So I just have a function called integrator function. So the input signal will get changed. So let's assume that you are passing the input voltage. So I'll call this function, and then what we will do is we will implement the we will implement this particular formula. So what is this formula? So input signal, previous signal value. So that is nothing but y of n minus 1. So this the previous signal plus the input signal into the sampling time. The value we got from the globally, and then it's available in the local. So we have updated this, and then we updated the formula, and then we are passing that value to the present output signal, and then we are returning to the present output signal. So you can see the value will get updated. Then I really want to repeat this experiment for 100 times. 100 times I want to just implement this formula. So now let's try to keep a breakpoint over here and then try to understand what does this means, or what is the how does this program works, right? So what I'll do is and just type make. Okay, so the program is ready. There is no more errors, nothing. And then I launch it. So what I'm interested is in this value, right? I'll just delete everything. Yeah, and I'll just type this. Yeah, and then if I try to do this, then you can see the value will get updated as 0.999 something. Why does it means? Let's assume you are having a. So what does this 0.99 means? So let's assume that you are having a constant signal 1. So in our example, we had seen the sampling time is 0.01. So 0.01 is nothing but 10 milliseconds. So if I try to in 1 seconds, then how many 10 into like 10 milliseconds we'll have. So basically we'll have 100 times. So if I try to type 100 into 0.01, so that is nothing but just close to 1. So if I try to take a constant and then try to do this, then you can see like exactly 0.01, it will just get accumulated, and exactly like at the end of 1 second the value will become 1. So that is what that is the reason why, just to show this example, I just tried to show you like with 0.01 as an sampling time. So now let's try to see the other part. Now again I is equal to 0. So again I'm repeating. Only difference is the sampling time is different. And now if you try to so maybe we want to continue. So now if you try to see this value, so that is nothing but input current dot signal. Yeah, you can see it will become 10 because the sampling time is remaining same, and still I'm trying to type like multiply or do 100 times. But in the actual scenario, if you have a the sampling time, it is really the program is getting sampled at 10 microsecond, 1 millisecond, 10 millisecond, doesn't matter. At the end of 1 second, the signal value will become 1 itself. Because if it is a 10 microsecond, then you are multiplying with 10 microsecond into TS. But every sampling time, you are calling that function, right? So that's what it means. So we have seen a simple example. So basically, we can see the the integrator function. We have just made it. Now, if it is in your actual embedded application, you just can create this function. If you have a sine wave, pass it a sine wave. If you do a proper integrator, you can see like what does the value comes. You can do a lot of experiments. One thing which is interesting is why I really passed the local variable, because the whatever till now we have discussed is nothing but called by value. So if you have a call by value, then like the value is only available in local. So you really want to store it in a global variable. So that is the reason why we are passing like the value in a global variable, and then so that in the next time when it calls, this previous output signal value will get stored. So we also in the coming lectures we will see how to implement the same using a pointer. Then you are not really required to have such a like passing the return value. So we will see that more examples in the pointer based programs. If you have enjoyed my video, we will have more insights in the coming video lectures. See you all in the next video. Thank you all.